welcome to another video. In today's video we are going to learn how to implement merge sort. Before implementing merge sort, I'm going to explain a little bit about how merge sort works. So let us consider some random example where the given array is consists of these elements 3, 4, 1, 2 and 6. So we want to sort this array in increasing order. So in order to do that, merge sort utilizes something called as divide and conquer approach. In every divide and conquer approach, we break down the original problem into smaller problems and we solve those smaller problems and integrate that result to get the required output. So here also what we are going to do is at each and every step we are going to break down the problem from the middle point. So let us say we start with this array in the beginning 3, 4, 1, 2 and 6. So this is the array that is given to us and I will write the index as well 0, 1, 2, 3 and 4. So for this middle index is 2. So we will break the array, that means we will partition the array into two parts here. So one partition will become 3, 4, 1 and another partition will become 2 and 6. So once we partition this, once again we can check. So we will keep remembering this original index. So this 3, 4, 1 comes from index 0, 1 and 2 and 2, 6 comes from index 3 and 4. So here also we will compute the mid. As long as we have elements which are greater than 1, as long as the size of the array is greater than 1, we will keep on breaking the array into two parts. So here also, since there are 3 elements in this array, we will split the array in the middle. So for this array, middle element is 4. So if we split array into two parts, we will get 3, 4 and 1 as the array. And here also if we split this array which contains only 2 elements, we will get array of 2 and 6. And once we have 3 and 4 where this array contains 2 elements, so we will split that array 3 and 4. Now the important thing here is whenever we have an array which has only one element, sorting that array is very easy. That is a very simple base case. So we will utilize the fact that if an array has only one element, that is already sorted, so that array itself will be the answer. So whenever we reach this stage, and what we are going to do is I'm going to write these return values. So when array has only one element, this is already sorted, so we get 3. And here also, since array has only one element, the sorted array will be 4 only. So once we get this sorted array from our sub problems, then we have to merge them. While merging them, we will go through the array, each array by keeping a pointer to beginning of those two arrays, and we will move based on the which element is smaller from that array. So when we merge 3 and 4, we will get 3, 4 in increasing order. And here also only 1 is present. The sorted array will also be 1. So now we have two sorted array. If we merge these two things, we will get 1, 3 and 4. While merging, we use a special technique that I am going to explain it later. But when two arrays are given which are in sorted order, we can easily merge them into a single array where each element in the array will be in sorted order. So we have sorted arrays from the subproblems and we are just merging them to get an array in the increasing order. And here also we get 2 and here also we get 6 because that is the only element which is present here. If we merge these two things, we will get 2, 6. Now we have this array which is sorted, this is also sorted. If we merge those two arrays to get a sorted array, we can get 1, 2, 3, 4 and 6. So this array is sorted. So merging is not just combining those two elements in random order. We have to check which element to pick. So based on the condition of which element is lesser, we will pick that element while merging. I'm going to explain each and every line of code by implementing the solution. Let's implement the solution to understand how this technique can be used to implement merge sort. Here is a question from HackerRank where they basically asked us to implement merge sort algorithm. So they will give input as n, that is number of elements in the array, and elements we need to print this output in sorted order. So we are going to implement everything. So in order to, we should get the elements. Let us say total length, and first we are going to get total length, that is scanf %d, and we are going to pass address of total length to scanf so that total length gets updated. And after that we have to declare an integer array of size total length, and for this we have to scan the values for I equals to 0, I less than total length, I plus plus, scanf %d, and we have to pass address of ARR of I. So this updates each element in the array. Now we have an array with the numbers. Now we have taken input. Now we have to implement merge and merge sort functions. So let us first try to understand how we are going to merge. So I didn't explain in depth how we are merging here, so I will explain that here. So let's say we get this call merge. Basically whenever this function gets called, usually the problem is with they will give two sorted arrays and we need to merge them to get a new sorted array. So this problem you might have already solved, but here instead of we don't get the two sorted arrays in this implementation, we can also do that, but to simplify our approach, what we can do is we can just get the index, that is left, right and middle. So we know that from left to middle there is one array, and from mid plus 1 to right there is one more array. So what I'm saying is, if I get this array and if I get these indices so 0, 1 and 2, I know that we are splitting the array here. So 0, 2 and 4, if I get these indices, then I know that how to split this array into two parts. So 3, 4, 1, 2, 6. So what I'm going to do here is whenever I get a merge, I will get an integer array, and one more thing I'm going to get is left, mid and right. So the first array is from ARR of left to ARR of mid, and second array is from ARR of mid plus 1 to ARR of right. So we are assuming that from left to mid is sorted and mid plus 1 to right is sorted. We just have to merge these two arrays and assign it to elements from left to right. So what will be the length of the first array? So length of the first array, let us call it as n1. That will be, if we consider elements from left to mid, length will be mid minus left plus 1. So this approach is let's say if you consider array elements from index A to index B, then there will be B minus A plus 1 elements in that range. So now we know the range, and this will be the number of elements which are present in that range. And what is the length of the second array? So that is this index, right, minus first index, that is minus mid minus 1 and plus 1. So this is the length of the second array. So we can, here you can see minus 1 plus 1, we can remove it because it results in 0, right minus mid. And after that, what we are going to do is we are going to create two arrays, that is A, let's say we call it as A of A1. This is the first array in which we are going to copy all the elements for int I equal to 0, I less than n1, I plus plus. So we have to copy elements from left to mid to A. So A of I will be equal to ARR of left plus I. So because we want to copy these elements into A, that is our first array is A, and we want to copy these elements into A. That is what we are doing here in this for loop. And after that we will declare one more array, that is second array, that is B, and we will copy those elements int I equals to 0, I less than n2, I plus plus. So here we have to copy elements from ARR of mid plus 1 to ARR of right to this B array. So B of I will be equal to ARR of mid plus 1 plus I. So we are just copying from these elements into B. So now we have two arrays A and B which are in sorted order. We just have to merge them before assigning to ARR or left to right. So for merging we can declare another temporary array that will be of size n1 plus n2, and we can keep a separate index, that is k equals to 0, while k is less than n1 plus n2. What we have to do here is, let's say if there are three conditions here possible, both we need another two index, 2 point A and B. So initially int I equals to 0, int j equals to 0. So this I will point to the array A, and j will point to the array B, and k will point to the third temporary array that we are going to create. So if I is less than n1 and j is less than n2, that means we are at valid index both for A and B array. So that time we have to check whether A of I is less than B of j. If this is the case, what we are going to do is we are going to choose elements from A. So temp of k will be equal to A of I. Since we have selected an element from A, we have to increment the index which is pointing to A. So we are just picking the elements based on the condition, whichever is smaller. So this is one possible scenario. Otherwise we have to choose element from B. So that will be temp of k will be equal to B of j. Since we have chosen an element from B, we have to increment j. So this is when both I and j are valid. So sometimes that A array will be smaller than A array will be smaller than B array, or B array will be smaller than A array. So that time we run out of elements in one array before choosing all the elements in another array. So in that case we have to check. Otherwise else if we can check only I is less than n1. If this is the case, we just have to choose should be equal to A of I, and we need to increment I, and otherwise we just have to choose the element from array B. So temp of k will be equal to B of j, and we need to increment j. So once we choose an element, we have to increment the k. So now we have sorted array in temp. We just have to assign this result into left till from left to right. So now what we are going to do is, once we have the temp, now temp has sorted array. Now we have combined A and B into a single sorted array. So assign temp array elements to ARR of left to ARR of right. So we will write one more for loop. Let's say int I equals to 0, I less than k, I plus plus, and what we are going to do here is ARR of another thing we can do here is we can also say j equals to 0, since we have already chosen. So another index j left ARR of j will be equal to temp of k, temp of I, we are choosing I gets incremented automatically. So we can also say j plus plus. Basically we are copying sorted elements into this array. So then this function will return. So this function, this is the logic behind merging two sorted arrays and assigning it back to the elements from left to right. So this is what merge function will do. So we have to write the main function, which is merge sort. So this is a recursive call where we will get int ARR, and we get left, and we get right. For this, first thing we should check is whether array has more than one element. So if array has more, that can be checked by checking whether left is less than right. If this is the case, that means we are considering more than one element. So if this is the case, we have to compute the middle element. Left plus right minus left divided by 2. So we compute mid like this in order to avoid overflow actually. So if you simplify this, you will get left plus right by 2, but if you directly write like that, there is a possibility that left plus right will overflow, integer overflow will happen. So this is the reason why we compute mid like this, but if you simplify this thing mathematically, you will get left plus right by 2. So once we have the mid, then we will call this function recursively. So merge sort of ARR, and first array that we are going to consider is from left to mid, and second array we are going to consider for sorting is mid plus 1 to right. And once we sort those two arrays, those two parts, we have to merge ARR left, mid and right. So this is the approach that we are going to follow. We just have to call this function here. So I'm going to call merge sort of ARR 0, and the last index will be total length minus 1, and after that I just have to print the sorted array. I is less than total length I plus plus. Printf. So we have to print in a certain format here. So this is the exact format. So I'm going to write certain conditions for that also. Printf %d and after that here we are going to print ARR of I, but we have to print it inside those brackets actually. So if I equals to 0, then we have to print an opening bracket, otherwise here also if I not equal to that is for the last element. If this is not the case, then we have to print a comma, otherwise else we have to print a closing bracket. I hope this solution works. Let us run the code and check whether we have done any mistakes in the implementation. Okay, this is some undefined variable int. Let's call it, declare that variable. Okay, I think we missed some bracket here in merge. Okay, this is not an int return, this is just a void. Let's run this code again and check whether it passes the initial test cases. Okay, the test case 0 is passing. As you can see here, this is the given array and this is our output. So let us submit this solution and check whether it passes all the test cases. Yes, as you can see here, this solution is passing all the test cases. So the technique is very simple. We just have to understand how this works and how we are merging these arrays. So I hope you like this video. If you are interested in learning more about other data structure and algorithm related problems, please check out other videos from my channel. Thanks for watching this video.